Well, now let's take a look here at example number 2. Suppose that a class has a final exam replacement policy, which students can take advantage of at the end of the semester. The policy allows them to earn extra points towards their final grade. In fact, we even have a policy like that in our class. Remember that if you earn a 70% or higher on the final, you can use that percentage that you earned on the final as your final exam score, but also to replace your lowest test grade. Now, some students might benefit from this policy and some may not. If you aced every exam during the semester, maybe you were not going to be able to replace one of those come the final exam, but you may not really need those many points at the end. If you happen to have a very low exam score, maybe your exam 2 didn't go super hot, no big deal. If you can perform well in the final, you can replace that. Well, let's suppose that a small sample of students were collected from the class and the number of points that were earned from this policy was recorded. So some students earned 1 point, like this person got 64 points in the class, that's a lot. Can we assume though, based on the data, that the points earned by all of the students in the entire class form a normal distribution? Well, let's see. Can you go ahead and pause the video here, see if you can create a normal probability plot, and see if you can then reach a conclusion about what you can determine about the points earned by all students. When you hit unpause, you'll see me work through the solution. Okay, so if you went ahead and you actually worked through this, you should first go to your calculator and type in all of your given information like I did here. Then you could easily go to your second stat plot and make sure that you have selected on the last type where your data is, and then hit zoom in 9. So you get a plot that looks like this. Now, does this look like it's in a straight line or that it's curving? Well, I think it's pretty obvious. This one here is curving. And so I could go ahead and try to demonstrate that I was able to make that picture by simply going here and trying to create or recreate that picture slightly. So I'm going to go ahead and I'm going to do this. And then I'm going to go ahead and put down a vertical thing that looks like this. And I'm just going to try to go ahead and recreate that picture slightly. So let's see, I had a lot of data values that were like down here, and then they started to move over and up, and then I had some points here, and then I had like 2 points over here, and then a point way over there, right? So this is kind of curving. It's not in a nice straight line. So I can reach the conclusion then that the data is not linear, and so I can answer the question, no. It is not safe to assume the points earned by all students form a normal distribution. Now, we can't be sure. I mean, maybe they do, but all we're saying is it's not really safe to make that assumption yet. We don't really have enough data to convince us of that. If we were betting individuals, we would bet on no. Okay, so when it comes to questions like this in assessments, again, I'm always going to try to make it really easy for you to tell if the data looks straight or if it doesn't look straight. If it's curvy, I'm going to try to make it really curvy, kind of like this picture was. And if it's straight, I'm going to make it pretty darn straight, like the last picture was. I'm not going to try to give you anything that's in a weird gray area. But that's really it for this section. It's a very short and quick section, and hopefully you'll be able to spot the times in the future when we're going to be interested in using this. Whenever we want to know if data came from a normal population and we're not told that in the problem, it's a perfect time to create one of these normal probability plots.